Welcome to Abhiyantrik's video channel. Myself Mallesh. So this is a dedicated channel for all VTU students and faculties where we cover latest subjects and labs. And this specific series of is dedicated for AIMl 7 semester deep learning and reinforcement lab. In this series of videos, we will cover completely the AML lab experiments, all the 8 experiments. But we will not go step by step in this first video. Instead, we will cover all the 8 experiments in Google Colab, how to run them, what are the libraries required to run in them, and how do you give the inputs and how to check the outputs. It is like a quick intro kind of thing. Okay, those who already know about the theoretical background of the deep learning and reinforcement link, for them this will be helpful. If you want more details, like detailed experiment details, like step by step running it, theory background on it, you can go through our additional videos which will be covering it in later on. So there we will cover explanation for each and every experiment, the concept behind it, and also we go step by step coding tutorials. And we will do it for majority of the VTU popular labs and subjects, so where we find new technologies. To begin with, this 8 experiments, we have a drive link where we have already created all the 8 experiments. You can click onto this link to download the experiments. Here we are downloading them. So this is the place where you can download it. So quickly, before going to that, I'll show you the experiment list. This is the VTU Deep Learning and Reinforcement Labs theory. And these are the 8 experiments we are going to cover. The first experiment is on word embeddings for any given words in the corpus. Next, deep neural network for classification, convolutional neural network for classification of images, then autoencoders for data compression on any image dataset, deep learning network for classification of text documents, time series forecasting, classifying the image using pre-trained model, then reinforcement learning example, that is simple grid word problem. So let us see how to run all these 8 experiments one by one. So as I given you this link, so you can all go through that link, and we'll also give it in the description. So now, these are the 8 experiments. So we have a first experiment. See, I recommend participants or learners, what you can do is, first you download this experiment list by clicking here and download. Okay, so this will download the entire 8 experiments along with the data sets required. So click on download. Once you download it, after zipping, it will download the experiments. Okay, the experiments has been downloaded. So again, I'll show you. Click here and download it. Okay, that's the option you have to do. It's for downloading entire programs. So I'll go to this download section. Here are my downloads. Right click and extract all. Okay, here are the programs. The next step is you need to upload this folder to the Google Drive. Okay, so let us upload it to the Google Drive now. So here in your open your Google Drive first. I'm opening the Google Drive. Okay, here first right click here and folder upload. Select those VTU DL and RL programs and upload it. It will upload the entire folder with all the necessary files. It is taking time, so it has been uploaded now. So we have all the experiments here. Now we can start running one experiment by one. Okay, first Let me start with the first experiment, word embeddings. Our first experiment, so that is word embeddings. So if you want to run this experiment, you need to install the GenSim. First connect here. There is a library required for running the all the word embeddings. Okay, so it gives you a lot of word embeddings. So we have popular word embeddings technology called as word to vector that is used here. Within word to vector, you have SIBO and skipgram. Okay, to install this, you have to do it for the first time. Uncomment this section and run here. This will install the GenSim to your Google Drive. So once the installation is completed, restart the session and make sure you will comment this one, because you don't need to install it again and again. Okay, now our session has been restarted. To run, this is the first part, step 1, where we declare some documents, any random documents, and this is the model architecture what is defined. So we can run through that first step. Then here we check for most similarity of any given input word. Based on this, okay, so it will learn how close each words are to another words. Okay, so for language, okay, so this is the outcome. The models is most close to the language, wherever language appears. So that is about your first experiment, word embeddings. Now we will move on to the second experiment, deep learning for classification. So if you want more details on the first experiment, please refer to the separate video which will be delivering it. So in this coming days. Okay, so like this you will be getting each and every experiment, means 8 videos for 8 experiment with the complete explanation. Okay, now going to the second experiment. To run this experiment either in local system or in your Google Colab, you don't need, in Google Colab no installation is required. For local system you need to install Anaconda and TensorFlow. Okay, to install Anaconda, Anaconda if you install, it will be useful for many experiments. So just search Anaconda here, and so this is where download. Now you can click to download the Anaconda installation. Okay, so you can go for downloading it. All right, so coming back, TensorFlow is not required to install because it is already pre-installed in Google Colab. Okay, so let me connect this and disconnect this experiment, because you cannot run multiple experiments at a time. Okay, the first part is libraries required, and this is a classification example, and for this purpose we are using a iris dataset. There are 2 programs are there. One is using iris dataset, okay, and we are reading that dataset. Then in next part we are taking the splitting the data into input and outputs, split that data into training and test, defining the model architecture based on the requirement. Then we are training it for some 250 epochs and evaluating the results. And you are also doing a testing on a sample example. So confusion matrix is will give you the how model is performing. In the second version of the code, we are using a dataset which is generated from this make classification. Okay, with the 5 features and 2 classes. This is some random dataset. So, but whereas this iris dataset it will has 3 possible outcomes, because Fisher iris data has 3 types of flowers, iris flowers information. So you can either use iris dataset, or you can go for this very simplified code, okay, which is very simple. You can see here, which uses the random dataset. Okay, that's about your second experiment. Now we'll move on to the third experiment, CNN using image classification. So this experiment is basically to use CNN for classifying the image dataset. To complete this, we will be using a fashion MNIST data. Again, installation is TensorFlow. and we are downloading importing the libraries required. Meantime, I'll close this connection. And you have to download the fashion eminis dataset, which has 10 categories of fashion items. And there are 60,000 images are there, 60,000 images, which will use it for training, and 10,000 images for testing purpose. More details will be provided in the separate video. So these are the sample images, and some pre-processing is applied. This is the model architecture, okay, and then you can start training your model. Evaluate and testing as a sample image, that can be done here. And again, the same code has been simplified, okay. So this is the simplified version with the minimum coding. So this can also be used for the third experiment. So next we'll go to the fourth experiment, that is autoencoders. Here output will be what? Predicting which image it is, okay. If I give some sample input image, so it will try to predict what will be the type of fashion object it is, or a fashion item it is. Since the training of CNN is still happening, so we need to wait. You can see here the training is completed, okay. So I have selected randomly one image. It looks like a trouser. We'll see what our model is. You can give the any number here, like if I give it as 500, it will show you the what is the image in 500 position. Okay, so this is like a sweat t-shirt. Let us see what our model will predict it as. Pullover, sorry, yeah, sweat t-shirts are pullovers. That's correct. So this is how you can check the CNN outcome also. Okay, so we'll move to the autoencoder. I already opened the program. Autoencoders are basically, almost neural networks, okay, where we can use them for compressing the images and reconstructing them back also. So here same TensorFlow library is used, and for this we are using a MNIST dataset called as handwritten digits. Okay, these are the handwritten digits dataset. Okay, so this is a simplified code where to run this one, again connect this. I'll disconnect this, which is already completed. Okay. The model architecture for compression, we are starting with the 64 neurons and then to 32, then increasing it back to the original shape. Okay, so you can start the training process. And this is the decoding. Okay, so once you complete the training, so you can check for any sample images, how it compresses them and how you can compare it to the original images. If you run this one section, you can see that original images are given here and corresponding compressed version of the images which are reconstructed. They look almost similar. You can also use some of the performance measure like SNR, PSNR to check how close the original image is to the compressed version of the image, that is a reconstructed version. Okay. This is about your autoencoder. So the simplest code has been provided. So yeah, training is over. We can run through some sample images. Yeah, you can see here 72104 has been constructed exactly as 72104. Next we will move on to the fifth experiment. Fifth experiment is classification of text data, and this is using deep learning. And for this experiment we are given I think 2 versions. No, single version only. No. And for this one we are using a data set called as sentiment.csv, which is available here in the uploaded files. Okay, what you have to do is first To perform the sentiment analysis, that is classification on the given data, okay, what kind of sentiment it is. There are three types of sentiments it can predict: positive, negative, and neutral. It can predict any three of them. Okay, but you need to make sure that you are connecting your Google Drive so that you can access this particular data set. Okay, I'll show you how to connect it to the your Google Colab file. This left side you have files option here. Click onto that. Then go here, mount the drive. Is asking me to run the code. Okay, you can run that code. Connect to Google Drive. Select your account. Continue. For some accounts it will do it automatically, means one click it will complete. Some accounts it will ask more details. Yeah, mount is done. Just refresh here. Now you can find your drive here so that you can collect the path. So VTU Deep Learning Lab programs. Okay, yeah, here sentiment.csv. Here you can click on these three dots to get the path. Copy the path and paste it here. Yes, that's it. So it will now start reading that data set. And this part we are defining the LSTM architecture. As I said, it has got positive, negative, neutral data set. Okay. So then you can run a LSTM model. Once the model is trained, okay. Once the model is, so here I need to enable this particular code. Okay. Once the model training is completed, you can give any random text to check the sentiment. Okay. So that you can do it here. So this is simple about how to run the fifth experiment, that is text classification. Now we'll move the sixth experiment, time series forecasting with deep learning. And again, this experiment is also using specifically the LSTM model, but I have given alternate example using the ANN also. Okay, you can use this using LSTM, and also alternate example using the ANN is also provided. But rest of the code remains same, only this model architecture part changes. One is LSTM, one more is ANN based. Again, for this we are using a data set called as air passenger, that is a time series data which we are using it. Additionally, you don't need to do any installation, so just you need to mount the drive in order to access it. If you are using your local system, okay, you need to give your path. Okay, the local system path has to be replaced here to read that particular file. Okay, so connect, click on mount the drive. Connect to Google Drive. It's asking again and again. Mounting the drive is completed. Now select that airpassenger.csv file. So as I'm repeating, I'm not explaining any programs here. Okay, for that you need to watch the separate video series. Remember that. So this is just video on how to run the programs. Yes, I given the path. So this is the entire code. I have not made any split onto this one. Okay, if it is required, you can split this into a first part will be reading your data set, and pre-processing, and remaining part you can go ahead with fitting this into a training mode. So it has completed the 50 epochs, and after that you can see that the time series is this is the input data forecasting, almost matching it. Okay. Similarly, you can do it for your ANN part also. Here also you should replace it and try it. Okay. So that's it about your sixth experiment. So this is the orange color one is trying to go with the input data, and this is the prediction part. Okay. This is also very much similar. Okay, so you can see that trend and seasonality, it has maintained that one. Okay, so then the forecasting is so good here in this case. So next we'll move on to the seventh experiment, transfer learning. This is a very simplest experiment, the transfer learning part. Again, you have to connect and mount your drive. I'll do that quickly. Connect. So drive is mounted. Select the path. Why this is required in this example case is because we are using a pre-trained model. We'll use that pre-trained model to classify in our input image. Okay, so we're using a RESTnet 50 along with the ImageNet weights. Okay, you can use any other models also. You can use GoogleNet, you can use AlexNet. So that depending on the requirement, you can it's not like a requirement. You can use any of the models to test it. Okay. Yeah, I have some images provided here, and I'll select one of the images. Means like dog image. I'm selecting it, copy it, the path, replace it here in image path section. So here no training is done because we are using a pre-trained model which already knows how to classify the image. ImageNet is been trained on 1000 different objects already, so that has the capacity to classify more images. Now I'll provide this to prediction part. Yeah, it is predicting this input image as Yorkshire Terrier with a 67% accuracy. So that's about the seventh experiment. Now we will move on to the eighth experiment, reinforcement learning. So this specific example uses the Q learning, and run through this program you don't need any installation. So this simple Python with the NumPy will be sufficient here. So in this experiment we are creating a some grid with a 4x4 grid with defined obstacles at particular positions, and these are the moves. Okay, and here agent try to learn, okay, how to move across and reach the destination. Okay, so for that several steps are there, initialization steps. 1 minute, so I need to disconnect other sessions. Yes, I had disconnected other sessions so that we can connect this and go ahead. Yeah, the step 1 is basically, as I said, initialization part, and here we are defining what actions to do. Like if you are so what kind of rewards to give it, okay, plus or negative rewards, and what are the parameters, how many episodes you want to run this one, that particular part. And here we are giving the training loop. This is based on this the training will happen. Once the training is happened, okay, it will extract the learned policy, and this is your final result after going through that particular policy. Okay, you can have your own policy and you can define your learning rate, gamma and all. You can change it into this experiment. It doesn't require any other inputs, other installations. This is a simple program. Here model, yeah, it's quickly learned. Okay, so here it is going through different steps. Okay, and it reaches the goal. G is the goal, D for down, up. Okay, obstacles, X are obstacles. All right, so this is your reinforcement learning. So what we covered is just how to run the programs. Okay, I'm not given any explanation of any of the experiments. Okay, for detailed explanation kindly watch the individual experiment videos. Thank you for watching. For more details, subscribe to our channel. Thank you all.